Hello, ma'am.
Hello. Hello.
Hello, ma'am.
Hello, sir.
Good morning, ma'am.
Good morning, sir. திருப்பி repeat ஆகுது.
லேட்டாக கேட்காதுல்ல நீங்கள் அதை கேட்காதீங்க இங்கே நீங்கள் கேட்டிருக்கீங்க அது
Halo Satip. Morning.
Good morning to all. Today, on behalf of the Vellalar College of Engineering and Technology, I welcome you all for the AICTE sponsored 6 days short-term training program Series 2 on deep learning applications and challenges in big data analytics. In this glorious occasion, I am happy to say we have successfully completed the Series 1 in the last month with the highly good feedback from the participants. I also like to thank our AICTE STTP coordinator for sanctioning the STTP for us. Now, I request our head of the department, Dr. V.K. Manavala Sundaram sir, to deliver the welcome address.
Good morning to one and all. Most respected management, Sri S.T. Chandrasekhar sir, our beloved principal and support for conducting this AICTE STTP program, Dr. M. Jayaraman sir, Dean Academics, Professor Peter Stanley Bibington, Dean Student Affairs, Professor Jayachandra sir, Controller of Examinations, Dr. K.R. Valluvan sir, heads of various departments, faculty members, and hero and heroines of this STTP Series 2 participants from various colleges, not only in Tamil Nadu, registered from 6 states across India, and the members listening for this Series 2 program. I welcome you all. First of all, I should thank our AICTE chairman, Anil Sagastrabude, for providing this opportunity, and director of this AICTE STTP program, hello. Sorry, unstable internet connection. The director of this AICTE STTP program, B. Venkat sir, for providing this opportunity and for motivating us in all those moments in Series 1 STTP and while starting the Series 2 FTP, and the changes that we have made. All the things have been approved by the director, Venkat sir. I welcome you all for this STTP Series 2. Now I will share the session details to all the members and participants. So starting from 7/9/2020 to 12/9/2020, in session 1, Introduction to Deep Learning, Mr. Deepan Raj from Embedded Software Engineer, Western Technology Services, Chennai. And in session 2, Big Data Analysis and its Challenges, Ms. R. Anureka, professor in the Department of IT, Institute of Road and Transport Technology. Today, session 3, Overview of Machine Learning, Ms. K. Vijaya, Assistant Professor, Senior Grade of Computer Science and Engineering, Vellalar College of Engineering and Technology. And in session 4, Evolution of Deep Learning Algorithms, Dr. S. Devi Suganya, Associate Professor in the Department of Computer Science and Engineering, Vellalar College of Engineering and Technology. So today we will be going to see the introduction to deep learning, big data analysis, machine learning, and evaluation of deep learning algorithms. So tomorrow, Tuesday, 8/9/2020, we will have the hands-on experience on deep neural networks will be taken by Mr. S.A. Jay Ganesh, software engineer from HCL Chennai. And in session 2, Also, a hands-on training on artificial intelligence with deep learning will be taken by Mr. S. Naveen, Senior Project Engineer, Pantech Solution Private Limited, Coimbatore. And session 3, Hadoop Architecture, HDFS and MapReduce will be taken by Dr. S. Sadish, Professor in the Department of Computer Science and Engineering, Vellalar College of Engineering and Technology. Tomorrow, finally, session 4, Big Data Tools will be taken by Dr. V. Srinivasan, Professor in the Department of Information Technology, Vellalar College of Engineering and Technology. And day 3, Wednesday, 9/9/2020 will also be a hands-on training on deep learning using Python will be taken by Dr. S. Kaniyamadan, Associate Professor in the Department of Computer Science and Engineering, Karpavam College of Engineering and Engineering, Coimbatore. Day 3, session 2 will also be hands-on training on machine learning models will be taken by Dr. S.V. Kogilavani, Associate Professor, Kongu Engineering College. And day 3, session 3, data management towards big data analysis will be taken as a hands-on training also with Mango database will be taken by Dr. R. Mainavadi, Professor in the Department of Information Technology, Vellalar College of Engineering and Technology. In day 3, session 4, real-time applications of deep learning will be taken by Dr. P. Navanidam, Professor in the Department of Master of Computer Applications, Vellalar College of Engineering and Technology. Day 4, Thursday, convolutional neural network will be taken by Dr. R. Srinivasan, Associate Professor in the Department of Information Technology, SRM Institute of Science and Technology, Chennai. And in day 4, session 2, no SQL database concept will be taken by Dr. S. Gobi Krishnan, Assistant Professor, School of Computer Science and Engineering, VIT, Andhra Pradesh University. And day 4, session 3, no SQL, a case study will be taken by Ms. M. Aruna, Associate Professor in the Department of Computer Applications, Vellalar College of Engineering and Technology. Session 4, Julia Interface will be taken by Dr. K.R. Anand, Professor in the Department of Computer Applications, Vellalar College of Engineering and Technology. Day 5, Friday, real-time applications of machine learning will be taken by K. Bhubadi Kumar, CEO and founder, Training Trains, Coimbatore. And in day 5, session 2, real-time sentimental analysis with NLP and ML will be taken by Mr. G. Palanivel Rajan, Senior Project Engineer, Pantech Solutions Private Limited, Coimbatore. And in day 5, session 3, usage of big data in deep learning algorithms will be taken by Dr. K.R. Anand, Professor in the Department of Computer Applications, Vellalar College of Engineering and Technology. And in day 5, session 4, scope of big data will be taken by Dr. S. Gokul Raj, Associate Professor in the Department of Computer Science and Engineering, Vellalar College of Engineering and Technology, Erode. Final date, day 6, Saturday, 12/9/2020. Research issues in machine learning will be taken by Dr. P.M. Arun Kumar, Associate Professor in the Department of Computer Science and Engineering, Karpavam College of Engineering, Coimbatore. Session 2, research issues in big data will be taken by Dr. S. Russia, Professor in the Department of Information Technology, KSR Institute of Engineering and Technology, Tirchangur. And in day 6, session 3, scope of research in deep learning will be taken by Dr. S. Jabin Begum, Professor and Head in the Department of Computer Science and Engineering, Vellalar College of Engineering and Technology. Day 6, session 4 will be an online test and valedictory function. So we assure, and the session is reframed based on the feedback provided in the session 1 of AICTE STTP session 1. We assure that we will make this STTP series 2 a grand success with fruitful information to all the participants. Now, I request our beloved principal, Dr. M. Jayaraman sir, to provide the inaugural address of this AICTE STTP session series 2 program. Sir, I welcome you.
Good morning to everyone.
Good morning, sir.
Respected Secretary and Correspondent Thiru Chandrasekhar sir, respected deans, heads of the departments, Convener of this STTP, Dr. V.K. Manavala Sundaram. Coordinators, Professor T. Nitya, Professor R. Makeshwari. Respected keynote speaker of today's first session, Mr. Deepan Raj, research engineer, product, it is embedded software engineer, Western Technical Service Center, Chennai. Faculty members, participants, good morning to everyone present here. I am very happy to associate myself with this inaugural function of the AICTE sponsored 6-day short-term training program on deep learning applications and challenges in big data analytics. On this occasion, we are very much grateful to the AICTE and also Colonel B. Venkat, Director, Faculty Development Cell, AICTE, for their support. As you are all aware of that, this is the second series of in the same topic. We have been continuously conducting various training programs, webinars, and workshops. And as you are all aware of that, the deep learning and the big data are the two front runners. It is going to be the major source for the generation of the careers and also for the young engineers down the line 5 years or 10 years. So that is why the AICTE is giving the permission to conduct so many training programs, especially for the faculty members. So unless otherwise, if you instill the confidence and the details and nuances of the latest trends to the faculty members, it is very difficult to develop the skill on the students. So this is the main outcome. You have to learn a lot for the next 5 days, and you have to proliferate whatever you learn from this STTP, and you have to convert this into first, you have to tell in the classrooms, and you have to give some mini projects, and you have to give some capstone projects. Then only you will get learn, and also that you can guide very well on the students. I do agree there are a lot of opportunities in this area, but that is misled by the various persons. The students are misled because knowing the surface level of the artificial intelligence or deep learning or whatever may be the data analytics, that is not enough. That period is over. There is no need to explain all those things, but they have to learn the fundamental skills for the prerequisite of the learning the deep learning or whatever may be big data. So a student should have the thorough knowledge in probability, statistics, and also the discrete mathematics, algebra, and other things. Without the fundamental knowledge of the mathematics, it is very difficult to proceed to the deep learning, whatever may be. So a lot of things are we are talking and we are giving the training, but especially you have to learn a lot and connect with the relevant and take back to the students inside the classroom or the online teaching and learning process. Then only the success will be fruitful. So I hope the 5 days will be very much useful for you. You have to deliberate whatever may be the talking for the next 5 days, and you have to take back and proliferate this message and instill the confidence, and we are in the phase of generating the career advancement for the students in this area. Wish you all the very best. Thank you.
Thank you so much, sir. I really thank you for your guidance and support forever. Now it's a time to request our speaker. Before that, I will welcome Dr. Srinivasan sir to introduce our chief guest.
Very good morning to one and all present for the AICTE STTP program. It's my great pleasure to introduce our today's speaker, Mr. M. Deepan Raj. He has completed his Bachelor of Engineering in Electrical and Communication at AICTE College of Technology and his Master of Engineering in VLSI Design and Embedded Systems at Madras Institution of Technology. His total work experience around 3.5 years. He worked as a research engineer dealing with product research by patenting new technological concepts at Agni Center for Research and Development for around 1.5 years. Presently, he is working as a software engineer dealing with artificial intelligence solution tools for automation at Viscount Technical Service Center around 2 years. He has conducted many corporate trainers in many places around India and also conducted workshops, FTTP program, guest lecture, some of his programs in IIT, MIT, VIT, etc. He has published more than 5 papers in national and international conferences. Some of his notable achievements are: he is part of an Indian book of record for conducting artificial intelligence workshop to more than 700 students in a single day. He was also appreciated in person by a former President of India, Dr. APJ Abdul Kalam, for creating a 5 feet cost-effective humanoid robot. He also won the International Award winner for contributing a real-time project using robots for easing the work of farmer in the farm fields. He also won the International Award winner for contributing a novel approach in effective brain-computer interface by coining a newer before concept named Neural Linguistic Dictionary. He also awarded with most impressive project of the year in IIT Kharagpur for ISRO Mars Rover Challenge. He also won 25 plus technical events in tech fields also all over India. We are very much happy to have an eminent person for this session. I welcome sir. I hand over the session to Mr. Deepan Raj. Thank you.
Thank you, sir. Thanks for this wonderful opportunity. Thanks for the management and for the staffs who work behind this. Let us start today's session. Without further ado, yeah, okay. So I believe that I need to get the. Can I get the host permission, sir, to share the screen? Yes, thank you. Okay, so I believe my screen is visible. So like today, I'll be focusing more on the introductory level of, what is deep learning, and there are a few terminologies which keep us confusing, right? So, what is machine learning? What is artificial intelligence? What does a deep learning does inside it? So we'll try to understand in detail about it, in this session. So as we already know that, there is another session which has happened, really good. The previous one, I could say that, AI is a new trend. I don't want to bore this, thing by saying what is AI. So everyone know what is AI, right? So I'm not going to go inside that. So these are few examples, which I can say that AI is pretty old. You could say, this particular movie is like 20 years back, which was taken 20 years back. I can say that. I mean, even during that time, I mean, people, I mean, have some knowledge on how to like showcase some things. For example, like a AI system is trying to understand the object which is front of it, and that too in the night time, and it is trying to detect the objects, such in something like a bike or something like that. So I could say that it's like an old field, but yes, I mean, it has gained lot of uh, appearances in this current time, because there are like, I mean, lot of, I mean, other parameters that can be considered because of this evolvement, but we could see those things later. But I could say that, I mean, even now, I mean, a lot of people have started to utilize, I mean, these concepts in a lot of movies right now. So like in Indian, so there are like few concepts where the robot tries to understand the gesture, the gait gesture of the particular human being, and tries to walk with the same gesture. And even searching the bags inside a deep water. So yeah, I mean, we might be sure that it's not possible for now, but I can say that these two concepts have been achieved right now. So people have designed I mean, a technique to detect the human skeletal pose. Based on that, they can even augment a human being on top of that. That is done. And recently, way more recently, Australian researchers have found a way to detect plastics, I mean, detect objects at underground, I mean, underwater sea. Because you know that, I mean, at underwater sea, I mean, we don't have much light which is going to be emitted, right? So I mean, even they have found that, I mean, an impressive way to detect those stuffs. So I could say that the advancement is very, very fast right now. But even because of these kind of movies, and the mythology is growing also very fast. People thought like, I mean, few things can be done by AI and few things cannot be done. So let me break these mythologies first. So before that, before we go to the actual session. So as I said, I mean, mythologies like AI is like human intelligence. So many people will say that AI is going to dominate human being, man. I mean, we are going to doomed. So I mean, a lot of things going to happen in the future. So a lot of, curse talks are happening right now, because people think that AI can beat human beings. I mean, I could say that it is not possible for now. I mean, we haven't I mean made a significant contribution so that AI can beat at every possible angle. Yeah, but yes, I mean, we have also made some I mean, substantial improvement in AI, where it can able to outsmart human beings at certain activities, but not in all the activities. That's point number one. The second thing is AI learns on its own. So it is never possible unless and until we give some input data to it. So if not, without having this kind of input data in the environment, it can never learn on its own. So that is also I mean, the second mythology. The third mythology is very, very important. Most of the people say, I mean, on a managerial standpoint, they say, I mean, Google have already done this, Intel have already done this. So but I can say that, I mean, there are no, I mean, 100% solutions which is tailor made to our particular problem. That's what makes this AI more beautiful and more encouraging for a lot of people. For example, let me take a biotechnological field. Okay, so in that, I mean, a lot of people, a lot of researchers have a lot of knowledge in that particular field. So they know how to make a research and how to find some new protein structure and stuff. What if they can able to transfer that knowledge to an AI engineer? Or like, what if they can able to learn AI on their own and try to implement this same technique with the system? So that is where it becomes more and more unique to each other, because he has gained a certain knowledge. With that certain knowledge, he could make up a system that could even replace, I mean, the day-to-day activities which he is doing right now. So it is a particularly unique solution which is given to him or given to that particular society, which not all companies can do. So that is the third mythology which I want to straight down, that I mean, not all are possible by the big giants like Google, Intel and stuffs. There are like lot of startups and lot of researchers are trying their way to implement their own new strategy with the help of AI. So these are the few mythologies which people keep in mind, I mean, while starting down a project, or like while like speaking about AI. So just we can shatter these things out right now. Okay, and we'll go to the AI part. I mean, what is actually it is. So as the name implies, it's like artificial intelligence. So for example, if we think and if we do something, we call it as human intelligence, because we're human beings and we have some intelligence, so we call it as human intelligence. What if this intelligence is transferred artificially, like to a system or like to a particular entity? So we call it as artificial intelligence. So it, as the name implies, it can do some operations. It can be equipped for an application where it can able to accept a minimal number of user inputs. Say for example, your TV systems or your washing machines or your AC air conditioner systems, everything works on their own with the help of a minimal number of user input. For example, your washing machine, I mean, you put your clothes there and you decide which mode to be washed. For example, it's a hard mode or a rough mode or even a soft mode can be adjusted in that buttons, right? So based on the inputs which we give, the washing machine will try to wash the clothes as per our instructions. So I could say that even a washing machine is an artificial intelligence system. So now people might get a lot of confusion that what I mean, even washing machine is AI, then what am I doing here, man? So there like a lot of confusions will be like rising around in your mind right now. But yes, I will say that even a washing machine, whatever system that works something on its own, can be termed as AI. So I could say that, I mean, on a pie chart, I could say that AI is this bigger circle. You can see that this big circle represent AI. Okay, inside which people thought of, I mean, creating some smarter application and smarter algorithm that paved way to machine learning. So which is actually a subset of AI. And even people thought that what if we can able to mimic the human activity, human brain activity. So based on that, I mean, this deep learning got evolved. So deep neural networks, I mean, CNN, convolution neural network, recurrent neural networks. There are like a lot of neural networks which is like happening in real time right now, right? So I could say that everything is a subset of AI. So, but I mean, as the layer goes deeper and deeper, the AI system gets stronger and stronger. So I could say that this AI is termed to be the weaker AI, and these two AI systems are known to be the stronger AI. So this is a weaker AI, this is a strong AI. I could say that washing machine and stuffs will come in this area, and machine learning, deep learning comes, like your face recognition or your activity recognition or autonomous cars, and no matter what, like there are a lot of applications which we can state down for that. So let me even break down into pieces right now. So before the introduction of machine learning and deep learning, people were introduced to this expert system, which we call it as AI right now. For example, your washing machine, or most probably in industries, right? In industries, people do automate lot of process because they know, for this particular thing to work, we need these kind of conditions. If I can able to satisfy this kind of condition, I could pretty much automate the process, because we know that, for example, let us take this LPW scenario. Okay, so I know a lot of people love cricket. So in this case, whenever a batsman is appealed for LPW, we'll be like watching the third umpire review, right? So on that time, when we get some parameters, like if the ball is pitching in line, or if the impact is on the stumps, or if, whether the ball is not higher than the stumps or something like that, using these kind of parameters, you would definitely conclude whether the batsman is out or not out. Let's say, for example, if the height is missing, you will say, hey, this is not out, man. You just arrive to the conclusion that the particular batsman is not out, because you know the rules very well than anyone in the earth, right? So definitely you could able to understand what is happening there. Based on that, you could create a condition for it. So that's what engineers do. So for example, for a system to work, we create rules. Okay, so in the form of a program, so like an if condition or a case statement, so whatever things which you do in your system, right? The programming, the basic programming, right? So using that, we create rules, we program it with the rules embedded to it. So the next time when I give an input to it, okay, the system will try to understand, based on this rule, process this input and give you the output, whether the batsman is LPW or not, out or not out. Okay, so that is how this expert system works. Yes, this works way more perfect, and even it is like it is very less prone to errors if the situation are limited and clean. Okay, but if the situation changes, if there are like lot of parameters to be included, on that time expert system will fail. And during those days, people started to understand, okay, I cannot do lot of automation with expert system, because it does have lot of precondition that has to be handled. So because of that, people try to evolve to a newer concept known as machine learning and deep learning. So let me give you an example. Okay, can we define a rule for this for the classification of number 7? For example, you can see, this number is written on a jersey that has a name on it, and there are like a lot of backgrounds here and there, right? And this is a computer generated image, which is a pretty solid number 7. And this is also a computer generated image, but it is not, it's like a fantasy number 7 where like a lot of flames are throwing here and there. Even this particular axe can also be termed as number 7. So now tell me, like, what are the rules can be given to this particular for this particular scenario, where you can define some conditions to it, so that we can able to differentiate between different numbers. Yes, it is a little tough challenge, right? So obviously we need to do some image processing techniques and find the width and length, maybe like find the, I mean, the slanting angle of it, maybe like give some conditions to it. But anyways, I mean, the rules will not work if your situation changes very bad. For example, this axe can also be termed as 7, right? Even this flame 7 is also be 7, right? But our human being have this cognitive intelligence to understand these kind of numbers, but the expert system cannot do this kind of activity. So that is where machine learning comes into play. So I mean, machine learning and deep learning are the current trend right now. So we'll try to understand machine learning first, and we'll slowly go to the actual agenda, deep learning. So as in this case, I mean, we could see, I mean, what we are going to do is we are not going to create any rules or any conditions for it. Okay, so all we are going to do is we are going to get the inputs, okay, from, like, for example, images or data, and give it and like feed the actual output. So this is the input and this is the expected output. Push this kind of data to my system. My system will form an ideology to understand like how it is working. So based on that, a model will be created. So once a model is created, when I like pass down an input, okay, so it will give you the output. I mean, as I say, for example, if the person is, I mean, out or not out, or like if the given image is having a 7 or not. So these are some of the, I mean, ideologies, I mean, which people are, I mean, using it in the real time right now. So yes, we got a chat. Okay, I'm not sure. Okay, sorry for that. So yes, there are like a lot of, I mean, things which we can do right now. But yes, for a machine learning or a deep learning system, we can incultivate, we can incorporate these kind of inputs to the same. For example, image, natural language processing, sound data, and even normal CSV or an Excel sheet data. For coronavirus situation, we people even predicted what will be the, I mean, the outbreak will be after 10 days or 20 days, right? So those things are like a data. So we can even process with data, with some sounds, like a natural language processing where we create chatbots and stuffs, and even image, we can do a lot of wonders, like, I mean, object detection, recognition, classification, and segmentation, a lot of stuffs. So right, so these are the prominent inputs that is used for a machine learning and a deep learning situation. So these are some of the application which is in the market right now, like Google Lens, Amazon Go, autonomous cars, even your I mean, your humanoid robots, right? So these are some of the application which is like a prominent promise for us to understand that AI is no far away from achieving. So even I mean, a lot of bugs are there, but yes, I mean, they have achieved it to a certain level where you can even use it in the real time use. So I mean, if you find some time, you can go to Google and, I mean, go to YouTube and type "I am AI." So "I am AI" is a video which is created by NVIDIA, the graphic card providers. So you could see like what are the substantial improvements which they have made in the current time. So that will give you a lot of insight about the the products which is going to be like, I mean, launched in the market right now. So another question will comes in our mind, like, why AI now? So why do I want to learn, or why do I want to implement this kind of situation, this kind of application right now? So is this the right time, or is it like too early? Yes, I could say this is the right time to like invest yourself in AI, because it's, I mean, there's a two deadly competition which is happening around here. One is the flood of digital data, right? The data is like too much. I mean, with us, we use Facebook, we use WhatsApp, we use Google. I mean, we search a lot, we travel places using maps, location, a lot of stuff. So, I mean, a lot of data is being collected by the private companies. So I could say that we could use those kind of data to do some good AI application for the same. So that is one point. The second thing which I can say is the computational part, because in the previous time, for example, like 10 to 20 years back, the typical powerful processor which we have in our, I mean, hand is the Intel Pentium 3 and Intel Pentium 4, right? So that is one of the powerful processor which we had there, I mean, during those time. And yes, I mean, imagine the RAM which we have is like 256 MB and 512 MB RAM. You know what? That is a very powerful RAM on during those days, even having a 80 GB hard disk. So this was a pretty badass configuration, I mean, during those time. But now even a I mean, a smartphone does have 4 GB of RAM and I mean, even 64 GB of storage space. So I could say that, I mean, the nanometers of the current processor is also like very lower, like 8 nanometer, 9 nanometer right now. So I could say that the processing speed and the power required is like it's like humongous right now, so that we could even do a lot of stuff right now. So that is what AI is being dominating right now. Because back in those days when I was like talking to an IIT professor, he was insisting that back in those days, if we create a small neural network, a multi-layer perceptron, okay, to create a regression problem, that is a huge deal for them. And dude, that took them 6 months to do it out, and even that took even close to 2 weeks to train that particular data. So that was a situation in back like 30 to 40 years back. But now we do have everything with us. So we do have the computational part, and even we have the data with us. So using this kind of information, we could do a lot of stuff right now. So let me cut short to this particular point. We'll go for the next topic. We'll deal with that later. So like to understand it much better, for example, if I say the word apple, okay, so a lot of objects comes in your mind, right? So for example, red apple, green apple, and apple logo. So as soon as I show this object to you guys, everyone who is watching this presentation can able to differentiate between red apple, green apple, and apple logo. It's because we have some intelligence on understanding these kind of object and differentiate them at a fraction of second, even less than a fraction of second, right? Because of the attributes of this particular object. For example, I could say, color, shape, and texture, which is combined together to create a unique combination for each and every object, right? Even you could differentiate between the same red apple, 2 to 3 red apples which is given to you. You could see some shape dissimilarities between one and two apples, and you can differentiate. It's like it's a small apple, this is a big apple, and it has a lot of pores and stuff, right? So by using color, shape, and texture, we could easily differentiate any object which is thrown to us. So that's how a human brain works. But yes, when I try to do the same to my machine, okay, so that there comes a deal, because machine learns it as numbers. So whatever it is thrown to us, it is going to think it as a number. So for example, I can even say that these number doesn't make sense to me. For example, I cannot say like this part of number represent the shape of the particular object, or this part of number represent the color of the particular object, or the texture of a particular object, right? But it's very difficult. So if we can't able to do some analogy, if we can't able to do some differentiation of these numbers, definitely we cannot provide some useful rules and useful information to our machine learning model. So this is known as semantic gap between human being and the computer. So human brain does things very differently. So we don't want to hard code this information into our brain. But for system, we need to hard code those information in the form of numbers. This is termed to be a semantic gap between human brain and a system. So let me just okay get okay, fine. So in order to do that, what people thought is like, what if I can able to do some create some algorithms, okay, based on the algorithms I could do some techniques to understand the numbers much better. For example, what if I can able to take the mean of R, G, and B of the given image. If I can able to sum up the numbers and take an average for red and green and blue, I could say that, for example, this is like the mean of R, this is mean of G, and mean of B, RGB. Okay, so in this case I could say that this is 0.66. It's like it is the dominant color. So I can say that this particular image is having a greenish color, which is the dominant color, right? So that's what that's what I can say. Like using these kind of algorithms, I could present the numbers in a much beautiful way. For example, giving some meaning to the numbers so that it can be processed to the next level, because this is the first important step that has to be that has to be taken care, no matter the input which you're going to provide. For example, even it can be a sound or an NLP or a data, we need to try to extract some important data from the same, so that all the data will not going to confuse my machine learning model. So that is where this feature extraction comes into play, and that itself plays a vital role in our AI system. And yes, there are a few categories of learning here. One is supervised and supervised reinforcement learning. Let me cut short to it real fast. So as I can say, supervised learning is something like, we have known data, okay, and we know that this data represent a red apple. Okay, so I just give this as an input, as in the previous slide, and the label to be the red apple. Okay, so red apple is going to be the label. So I'm going to push this information to my machine learning algorithm. Okay, my algorithm is going to process and the model is going to be trained. So whenever I'm going to give a query data, okay, so if the query data is given, my new response is going to be created like, okay, this is an apple. So because I have learned a lot of information from these kind of images with the actual label for it, so that I'm just supervising the learning, so that my system can able to understand this kind of system like we do in our college days or in the school days where teacher teaches the students. So whatever teacher teaches the student will able to understand that particular nuances. If the teacher shows a orange and says it is like red apple, the student will learn it as red apple, right? Because they don't know anything about it. So likewise, for example, if I can able to take a numbers, okay, it's like a mean and standard deviation of the given images. Okay, so I have 3 images of apple and 3 images of mango. Okay, so as you can see, we do have numbers like this, right? So what I'm going to do is I'm going to extract these features like this. Okay, and I'm going to push these information. I'm going to say, okay, if I get numbers like this, if I get a bunch of numbers like this, I need to say it as red apple. If I get numbers like this, I need to say it as a mango, right? So we're going to like supervise the learning by giving the data and the label to the machine learning model. So the next time when I encode some numbers which is similar to this category or this category, it will say whether it is an apple or a mango. So that is how supervised learning works. But when it comes to unsupervised learning, okay, like we go to a different country or a different state where we can able to we can't able to understand the words in the posters, right? For example, if you go to I mean some other foreign countries where it is written in Spanish, you cannot able to understand like what are the characters represent. But yes, you can able to differentiate like this is something different new language which is not equal to English or not equal to my native language, right? Because you know that you don't know the actual label for it, but yes, you can able to differentiate it by finding a pattern to it. Likewise, when it comes to unsupervised learning, we push the images or the data to the machine learning model just like that. The model will understand and it will try to find a pattern for it. So once a pattern is found, it will try to cluster things up. For example, these are a different pattern, I'm going to cluster it to a different class, and this is representing a different pattern, I'm going to like cluster things to a different class. Okay, so in a numerical standpoint, we don't have the labels at all, right? So we just have the data. So during this time, what I can say is, for example, 120 and 121 is like closer to each other. Even this this is having 120 and 124, right? So I can say when I get data like 120 and 124, definitely it's a separate cluster. So whenever I get an input number like this, I'm going to say this belongs to a category A. Likewise, I'm going to find some pattern in these numbers and I'm going to cluster things out. So that is how an unsupervised learning works. So in order to like differentiate it much easier, for example, I have a data in supervised learning, I have data and a label. So I like create the algorithm and I create a model. So whenever I get an input data, it will give me the label of the particular input. But whereas in unsupervised learning, we have different varieties of animals, right? So we don't have the label for the same. So I'm going to cluster things out, but not by giving duck or not duck, but clustering based on the shapes. For example, these three are birds, these are like animals, like walking animals, right? So I could differentiate with them by using some clustering technique. So that is how an unsupervised learning works. Yes, these are the two predominant things which is being deployed in the market right now. And yes, the next thing, reinforcement learning, is also being achieved by it right now. But I could say that there are like no more better application which has been deployed in real time, because still it is in the process of evaluation and stuff. So as the name implies, reinforcement learning, it learns something on its own. It's like simulating the environment again and again. So all we need to do is create an environment. Okay, create an environment, give the possible set of steering point, for example, like an action. Okay, and set up an assessment. So let me take a scenario, on a driving scenario. Okay, so it's a single lane road. I design a artificial intelligence car, okay, which is going to overtake another car, something like this. Okay, so it's a very narrow space, so the car will find it very difficult to overtake this truck or a vehicle, right? So I'm going to give this situation to my actor. Okay, so my actor is going to perform action to the given environment. So based on the environmental change, I'm going to assess it out. For example, the car should cleanly overtake the vehicle in front of it and into like smoothly transit, not by ramming down with the post lamps or not adhering to the to the traffic signs or something like that. So it should be like very clean and neat, like a professional driver. So based on that, I'll be getting a 5-star rating. So if the environment change is very bad, I'm going to reduce the rating to 1 star or 3 star, something like that. So now whenever an actor performs an action, the environment changes and an assessment details which is given to it. So based on the assessment, it is going to be given as a feedback to the actor, and the change of state is also given as a feedback to the actor. So the actor will understand, okay, I'm doing it very bad, let me try to change my actions. So it will simulate million number of possibility actions to that particular environment and try to achieve a 5-star rating for the same. So now I could say that for that particular situation or to that particular environment, my actor can outsmart anyone in the world. But yes, it cannot be like deployed for all the environments in a real-time driving scenarios, that too particular in India. You know the drill, right? So it's very tough to, I mean, follow a lane and, I mean, beat the traffic. So it might be a little tough challenge to create an autonomous car in Indian driving scenarios. But yes, I could say that, I mean, people are trying to do that as well. But this is a very important thing to be noted down. It's like it is something it is doing on its own, but not typically everything on its own. So it is like, I mean, relying on the information which we give to this system, for example, the environment and the assessment details, which is given as a feedback to the actor. So based on that, it will able to respond to a particular state. So yes, I mean, we saw a short introduction about machine learning, right? And even the basic concept of embedded, I mean, expert system and stuffs. But yes, we are going to like go inside the actual concept on a deep learning, because I felt that without getting some actual introduction about machine learning and expert system, it might be a little tough to comprehend what is deep learning. So we're going to get deeper into it. So let me give you I mean, a head-to-head comparison between machine learning and deep learning. Okay, so machine learning, what we do is we gather the data set, right, and we extract the features. We human being will see the data set first and say, okay, for this particular data, let me go for color based information. So color based information is more than enough for me to, I mean, comprehend to achieve this particular output. So we sit manually and we analyze the patterns and say, okay, for this particular input, for this particular application, color based features very important, or like textural based or shape based information are very important. Like we feature engineer, we extract features, we create the algorithm for it, and we push to a classification system. So the classification system is going to be the machine learning model, which is going to learn from the pattern which is given by us. So and then we get an output for the same. But in deep learning, everything is going to be stacked up into this neural network. So where the feature extraction and the classification is going to be done on a single row. So we are not going to like get inside this to this layer at all. So we don't do any feature extraction just like that, but everything is going to be learned by the deep learning, by the neural network on its own. So that's the beauty point of using machine learning and deep learning. Yes, we do have differentiation of machine learning, because sometimes when the environment is constrained and we don't have much data to be utilized, on that time machine learning will be dominating the application. But yes, if you have a very large data set and your environment is not constrained, for example, like autonomous cars, where it need to drive on the road without I mean, ramming up any human being or pedestrians, on that time definitely deep learning will be like much more useful. Maybe on an industrial standpoint, maybe machine learning can be used effectively, but on a normal, on a real-time scenario, deep learning will dominate. But yes, there is also pros and cons for machine learning and deep learning. So it's all because of the data which we have right now. So we'll understand in detail about what deep learning does. But before going there, I just want to ask you a question. I mean, what this image represents. So can anyone say like, what is this image? Any idea about it? Any wild guesses? I mean, of this image. Oops. Any guesses? Yeah, smiley. Yes, absolutely. So even, I mean, even just by seeing the colors and the some different vectors like this eyes and shapes, we definitely say this is a smiley. Like this, I mean, the deep learning works actually. So it will construct piece by piece information altogether to create an, I mean, to create an understanding of a particular image. So that is how a deep learning works. So it will try to understand the low level features and slowly like gain, I mean, attention to the mid level and to the high level features. For example, for a face recognition stuff. So for a face recognition stuff, initially it will be like detecting the, I mean, the lines and edges of a particular face, and then it slowly gains attention by altering its filters okay, to understand the local features like the mid-level features like eyes, nose, ears, and stuff. And later on, the filters are adjusted way more perfectly to understand the entire set of features. So I could say that deep learning like doesn't require any handcrafted features. That's one, and which is going to be very time consuming, and it is not scalable in nature, because in deep learning, even though when you have like 1 lakh data, you don't want to worry about much, because more the data, better the deep learning will work. But for machine learning, things are very different, because in that 1 lakh data, we might have some anomalies that might, jeopardize the entire machine learning algorithm. So that's what we call the deep learning. Definitely do contributes a lot to the society, but a lot to the real time world. But yes, machine learning is something like where it can able to adjust things on a, on a certain standpoint. Okay, so we'll understand the neural networks in detail right now. So because these are the basic points, because as the principal sir told that we are just looking on the scratch of the surface, we just want to understand it much detail, so that the next time when you're going to implement some stuffs, we can able to easily comprehend to the mathematical background to it. But yes, mathematics is little tough to to digest in the beginning, but yes, as the day goes and you will get a good hold onto it. But I'm not going to go into mathematics in detail, but I'm going to give you a deeper insight about the contents, the layers which is being used in the neural network. Because neural network is being developed and it's been like inspired by our biological neuron, right? The neuron, the very neurons which is connected all together in our human brain. So the entire neurons are connected together to form a neural network. So that is how our human brain works. It passes down information to neuron to get some output for the same. So people thought of using the same information and using the same ideology to create an artificial neural network. So as you can see, this input layer will be like getting the data, getting the input data, like for example your senses like vision, nose, ears, mouth. So like there are a lot of inputs which you're going to get, right? So those kind of input is going to be gathered by the input layer, and I'm going to give the output, the processed output. In between, I'm going to have some hidden layers which will do the processing for me. So it's going to find the pattern, it's going to extract the features, and it's going to give me the actual classification output. So everything, the hard work is going to be done by the neural network and not by us. So all we need to do is we need to design this neural network in a way which is more robust enough to understand the particular application. Okay, so let us understand the components one by one. Okay, so the building blocks of this neural network is the single neuron. So let me understand, what are the components in this neuron. So one is like the input. Okay, it gets an input obviously, and it gives you an output. So it is typically a passing function where it will try to pass this input based on the weight and the activation function. So this activation function is like a gatekeeper. Okay, it's like a watchman who's going to sit down in this neuron and going to understand and going to like look for the inputs. So based on the threshold weights, so it will say when a particular person is having a car, or maybe is looking good, he will pass that to the output. If the person is not looking good, is coming in a bicycle and stuff, and maybe it's not allowed to go to this particular place, something like that. Maybe I'm not discriminating it, but I'm just saying as an example. So based on the weights, this will act as the weighted package. So based on the weights, my activation function will respond to the inputs, and based on the inputs, it will understand whether to pass this input to the next layer or not. Likewise, it will happen for each and every neuron in a neural network. So no matter what is an hidden layer or an output layer or an input layer, everything accepts an input which will be having a weight, which will be having an activation function, and which is going to have an output function as well. Okay, so that is our neuron. I mean, decide things. But yes, we will be like understanding in detail about it. Now, for example, when I have an input image, for example, a 28 cross 28 image. Okay, so imagine 28 cross 28 will give you like 700 and some numbers of pixels, right? So I'm going to pass entire pixels to this particular neuron. So here you can see, all the neurons have been splitted, and all the data have been connected to all the other for example, this neuron x1 have been connected to the all the immediate next layer of hidden layers, and for each and every input pass, it is having a weight function. So based on this weight function, it will it will understand whether to pass this particular x1 to the next layer or not. If not, it will discard this information. Maybe it will pass the x2 to the next level. So it's based on the weightage of these three inputs, it'll understand which data is worth passing in this neuron and this neuron and this neuron and this neuron. So it's like a weight into the actual input plus some bias. So obviously we should have some bias. Without bias, things might go very crazy. Okay, so that's what the implementation is given here, like a summation of wi into xi plus a bias factor. So let me say, yes, obviously, the important factor to be considered is the activation function, the gatekeeper, which I told you, right? So based on the gatekeeper, a lot of things will happen. For example, if I have a step based gate function, like an activation function, so here you can see, for step activation function, it will look for a threshold, for example, 0.5. So whenever a data is like above zero point 0.5, it will pass that data to the next layer, else it will definitely neglect the data to be passed to the next layer. So during this condition, when initially people were using this step function as an activation function, but it was not significantly helping a lot of things, because sometimes maybe a data it's like zero point 0.3, okay, will be like very important to that particular output. But if, since because of this step activation function, this will not be passed to the next layer, and that will jeopardize the entire neural network. So because of that, they discarded this particular step function, and they, even try to go for linear activation function, a lot of activation function, and finally they arrived to an activation function known as ReLU, rectified linear unit. So where you can see it is a combination of a step function and a linear function. So but the step function is limited to 0. So whenever I have a data, okay, so whenever I have a data which is above 0, I'm going to pass it just like that, like a linear activation function. So here you can see max of x comma 0. So if it is greater than 0, I'm going to pass it just like this, based on the number intensity. So since it's linear regression, linear activation function, it will pass down the information based on the input which is given to it. So it terms to be one of the best activation function for your neural network. No matter it can be convolution neural network, or your normal multi-layer perceptron or deep neural network, ReLU is termed to be the worthy candidate for your neural network. But yes, there are also certain other activation functions like sigmoid or hyperbolic tangent function, where it also predominantly being used in the recurrent neural network, your time series problems and stuffs. On that time, sigmoid and hyperbolic tangent are being used, because and predominantly this tanh function, your sigmoid function, is actually will be like helpful to classify a particular data to be 0 or 1. It can be used on the as an activation layer for the output neuron, rather having it to be in the hidden layer, okay, because in the hidden layer, ReLU function will be like predominantly being used, but in the output layer, it is always better to go for a probabilistic output. For example, if the given output is actually a 0 or 1, for example, an LPW situation, all we have is two outputs, either 0 or 1. 0 represent not out, 1 represent out. So during that time, maybe this sigmoid function can be like used as an activation function at the output layer, so that I will be getting the right output at the right time. Yes, hyperbolic tangent function can also be used during the recurrent neural function, but this is not the scope of this particular introduction, so we'll go for the next slide. So one such beautiful implementation, representation of ReLU function. So whenever I have a weight and with a bias which is less than 0, okay, if I have a bias, when I add a bias with the weight and the actual input, and which is actually lesser than 0, my ReLU activation function will never going to pass to the next layer. Okay, so and also another point to be noted is like, this is how the strongness of the activation function look like: linear, sigmoid, tanh, ReLU, and leaky ReLU. Yes, there's another implementation as leaky ReLU. It is like a supervised like superior activation function to ReLU. So where I can able to even pass down data which is very close to 0, for example minus 0.01 or something like that. Even people found that, during some research works, they found that even passing down some close to negative or close to 0 values can also comprehend, can also like help the neural network to learn something on its own. So as I was saying, learning, this is where the learning comes into play, because you know that we have some weights, we have some activation function, but how does a neural network works, how does a neural network learns on its own to understand which are the important features and which are not the important features to be considered. So this is all done by the concept known as back propagation. So back propagation is a very important topic that has to be considered, that is like considers a feedback to the neural network. Let me take an example. I do have an image which is having a character A. Okay, so I'm just considering a 28 cross 28 image which typically has 784 pixels. So obviously this input neuron will have 784 input neurons. So I'm going to go, I'm going to pass this to two hidden layers and one output layer. Okay, so in this output layer I have three neurons where I'm going to, I'm predicting three characters A, B, and C. Here you can see that it is giving 0.3 probability for A, 0.5 probability for B, and 0.2 probability for C. Okay, so which is actually very bad because this is the actual value A, but it is like giving more weightage to the answer B. So it is definitely wrong, right? So as you can see, this is the actual prediction. Okay, actually it should be like zero point 0.9, zero point 0 something, and zero point 0 something. Okay, so this is how the actual prediction should look like, but the prediction done by the neural network is this. So I could say that the deviation between the actual and the predicted value is going to be +6, -5, and minus zero point 0.2, right? So there is a huge difference. There's a huge difference of error rate which is produced in the output. So based on the input data and the label, it will try to understand what is the actual output, and based on that it will calculate an error. So we call it as a loss function calculation, so like error rate. So based on this error rate, I am going to back propagate to my neural network and saying, hey man, this is not the right way of predicting things. Try to adjust your weights, because we cannot change the activation function, we cannot like change the watchmans and stuff, but yes, you can give some predominant input, like even look for people who's like good looking. Maybe if they are a student, definitely you should like allow him to the college, rather having some politicians and other stuff to be like going around. But yes, like this, I'm going to like push some information based on the error rate. I'm going to adjust my weights. So based on the weights which is adjusted to the each and every neurons, I'm going to like pass the next data to it. The next time my error rate might increase or might decrease. Based on that, I'm going to again back propagate. I'm going to take, okay, we are progressing very good. We need to update the weights again to a better note, so that we can able to do a better job. So this is how a neural network learns something on its own, like back propagating and updating the weights. But yes, updating weight is not a that simple task, because imagine I have 784 neurons, a lot of hidden neurons which is inside it. So updating weight for each and every neuron is a very tough job, and to understand which neuron is very important to me is a very tough challenge. So that is where lot of optimization technique have been being used currently right now. One such example I could say, it's like gradient descendant. So this gradient descendant is the actual guy who is going to understand the pattern of your error rate, and based on that he's going to update the weight. He's going to say which weight to be updated during which input pass. So for example, if I throw a ball on a high steep hill, the ball will try to slowly, for example, maybe the ball is here. Okay, so let me say the ball is here. It will slowly gain margin during this time, right? Slowly go down, and suddenly it will gain a lot of momentum and go very fast to the down angle. So I could say that this particular region is a momentum, right? So it is like giving me a great momentum, so that I could say that, okay, during this time, maybe if I, for example, if I adjust a weight in one neuron n1. Okay, let me take neuron n1 and n2 and n3. Okay, so I adjust weights in the n1 neuron. Okay, so during this adjust of weights, my error rate have gained a great momentum to reaching to zero. So because of this momentum, I feel that, okay, this is this is the actual candidate that is actually like helping me to find the exact results. So I'll try to fine tune this n1 neuron again and again to get even the less error rate. So as much as the momentum is gained, for example, it will go till here, and even it will start to go up because of the momentum which you're given, right? So and we understand, okay, the error rate is increased. Maybe I should stop to fine tune this n1 neuron, maybe go to the n2 neuron to even fine tune this weights. Likewise, it'll go here and go here, something like this, and finally reach to the bottom point known as global minima. So this point is known as global minima, and this midpoint is going to be the local minima. So by understanding the error rate much precisely, this gradient descent will try to understand which weights are important to this particular input pass, and based on that, which can be like mitigated, and which can be like updated in the real time node. So that is the one of the important point to be considered when you're going to update a weight. So this is where our algorithm strong point comes into play. There are like lot of techniques like stochastic gradient descendant, mini batch descendant, vanilla descendant, RMS prop. So there are like lot of techniques are there available for gradient descendant. I could speak all day along like for this particular gradient descendant, but yes, since the time is of the essence, let me cut short the next slide. So I'm not going to go in detail about this convolutional neural network, but yes, I from the agenda which I heard, there is a separate session for convolutional neural network. But yes, to understand much better, neural network will works better for a lot of data, but it will not work better for a for an image input. So for images, things have to be done very differently. So because of that, people try to create a particular concept known as convolution neural network, where they try to convolve image and reduce the dimensionality of the image to get the important data of the particular image. For example, in this case, okay, the important thing is like the background is not needed for me. So even this is not, only this particular guy is important to me, and this particular football is important to me. So what if I can able to reduce the dimensionality of this image and get the important numbers which is actually represented in this particular image? So that way this convolution neural network will work. So I could say that just let me like cut start to the basics. Yeah, these are the layers which I can say right now. So one is the convolution rail, which will be having the activation function, where I'm going to create some filters. Okay, so using those filters, I'm going to get some data, and I'm going to do some pooling operation where I'm going to reduce the dimensionality of the image, and then I'm going to like push two different layers to get a output for the same. So I'm not going to go into detail about this CNN, since I don't want to jeopardize the other speakers who are going to like speak on this particular topic. So let me like cut short to the next topic. So maybe I could give you a visualization about how does a neural network will look like on an implementation standpoint. So let me share you one video. I guess you would have watched this video if you're a neural network enthusiast. So for example, to classify numbers, okay, from 0 to 9, how does the activity of a neural network will work? For example, perceptron. So this is how my multi-layer perceptron will work. So we'll go to the neural network, so that will give us a lot of good insight about it. So this is normal, this is a perceptron. So this is how it activates layers and activate neurons, and based on it, it gives me the actual predicted output. So now let me go for multi-layer perceptron, which is actually your multi-layer neural network. So as you can see, let me parse it right now. So here you can see this is the input layer, right? This is the input layer, and this is the first hidden layer, second hidden layer, and then I get the output like this. So when I play it, so I have three hidden layers, one input layer, this is got my input layer, 1 2 3 hidden layers, and finally the output layer like this. So as you can see, this white pixel represent the activated data which is going to pass to the next layer, and the black pixel represent the deactivated data which is not going to pass to the next layer. As you can see, the activations are very high in this first layer, but in the second layer the activation is like little less, because it has fine-tuned the important categories, and even in the last layer the activity is very less. And finally the activity is like going to a single probability score of whether the given input image is having 0 or 9 or 1 2 3 4 5 7 8 9. Okay, so this is how an multi-layer perceptron works. But yes, it cannot be like 100% successful, because if the position of the data changes. Okay, so so this is a neural network. So when it comes to convolution neural network, so this is the max I can show you right now. So here you can see convolution works way more differently than your normal multi-layer perceptron, because in a multi-layer perceptron, so here you can see, this is your multi-layer perceptron, this is your fully connected layer which you have here. But we do have a different convolution layer and pooling layers, which will try to understand, it will try to filter out different information. Like for example, this 9 have been filtered out different, right? So this is a 9, this is 9, this is 9, this is 9, everything is representing 9, but in a different form factor. So maybe this kind of data are very important to me, not the entire set of images. So I'm just extracting some useful information and try to even discard the unwanted information by using pooling layers, by reducing the dimensionality of the particular image. So once the dimensionality of the image has been reduced, I even connect it to a normal neural network, like a fully connected layer. Based on that, I'll be getting the output. So you can see the neuron activity is like pretty neat and clean. It's like very fast, than we think of. Yes, it is like much more easier for the neural network to handle a little amount of images. For example, if I have 1,000 x 1,000 image, imagine like how many new input neurons I will be having it. So 1,000 to 1,000 will be giving it 10 lakh input neurons, which is going to be a very complex neural network. So people thought of creating some image processing stuff by using convolution and pooling layers to reduce the dimensionality of the image, so that the very input will be like reduced to close to 1,000 or 2,000, rather going for lakhs and stuffs. So these are the things which you want to keep in mind when it comes to a normal neural network and stuff. So yes, I could even show you a lot of, other things as well. But since time is of the essence, there are like a few, real-time discoveries which is made. For example, in silico medicine, on drug discovery. So you'd have heard about that. A typical drug discovery will take 7 days of time to do it. Once the components of the formula is found, it will take 7 days to find the actual proportion of the component to create a tablet. But yes, in silico medicine has broken this. Thing by like doing it in just 6 to 7 hours. So it is actually like, i mean i mean uh, smarter than the human beings. But yes, it's one of the alpha go movements in drug discovery field and even AI field. Even in diagnosis of terminal cancer, Sophia Genetics has been doing a great job where you can able to understand the terminal cancer, even the early stage, way more precisely than the human being does. So likewise, there are like lot of improvements which is done in real time right now, like even meta chips, the Neuralink, which is done by Elon Musk, the recent trend which is in the market right now, right? So you have created a chip that can able to simulate the neuron activity, even for I mean. For people who can't move their arms and due to the heat strokes and stuffs, due to the strokes, they try to simulate those, neural activity so that they could even reuse their hands and arms just like that. So I could say there are like lot of research which is happening in the real time. Just try to, sit down tight to understand all the nuances and try to understand the basic mathematical part behind it, so that we can able to do, a lot of wonders to the same. So and although some significant importance in the agriculture point is the autonomous tractor. Yes, it is. It is also doing a great job right now. Even drones that can able to understand the weeds and spray some pesticides, even spray water for a less watery conditions. So yes, people are doing lot of stuffs right now. So and also the market of AI is like very huge right now. So lot of billions of dollars have been invested on different fields. For example, for predicting the stock market, I mean 70 billion US dollars have been like invested for the same. So even for agriculture, Amazon, Bosch, and Bonnyrop have been like closely like doing some, research on doing some agricultural products. Even for autonomous driving car, Google is doing it a very good job. Bionics, medical, military, you can name it. Any industry you can go, you have a huge source of fund, with you guys. So definitely, you could try to go there. So some of the current trends which I can say for research standpoint, if you're going to if you're going to dedicate yourself into research, definitely you can go for generative adversarial neural network. So generative adversarial network is something which is a new topic where you can able to generate images out of a context, like an artist. For example, if I can able to create a system that can able to mimic my human body, okay, on any instances I can, like an artist, that is a very wonderful thing to be considered, right? So that is what generative adversarial network does. And even chatbots is like growing very fast right now, because all the customer surveys have been like first, pushed to this chatbot, and later on it goes to the we are like, going to the actual customer relationship managers. Let me show you a video about how this generative adversarial network works. um, Yes, a recent, near recent paper which is published, where they can able to do some one-shot recognition of human faces and generate images. So, for example, this is a living portrait, so it's just one portrait, which using this one image, they create a lot of portions of this particular face. So imagine if I can able to get one face and mimic, different poses and gestures. It's like a real thing, right? So you can see, a lot of old pictures are being done. Even see Mona Lisa is like speaking to us right now. So it's like she's making cute, expressions and stuff. With just one image, we can do a lot of stuff like this. So that's what the current trend is happening right now. So even I could say Albert Einstein is also like speaking to us right now. So it's a like wonderful notation where with just one image, we could even generate a lot of other images as well. So is one such important topic which you want to consider, doing or like having it in your research pocket. Okay, so that's it from my end. So maybe like I can show you some live demonstration on like how does a neural network works way more better, to understand or like can be utilized for a situation like this. For example, let me show you a demonstration of to detect face masks. Maybe that might comprehend to the actual curiosity, right? So for example, I have a system. Okay, during this coronavirus situation, people are trying to do this particular application again and again and again. So for example, if I see, the face is detected just like that in real time, and it says there is no mask which is present. So when I try to take a mask and put it on my face, So it says there's a mask. So mask and no mask. So it's one of the simplest algorithm which I can say, which took me just 2 to 3 hours to do it out. But yes, it's a very easiest way to do a lot of stuff with the help of vision based systems, because using computer vision and stuff, we could do even a lot of good application, in using deep learning and stuff. This was done using deep learning, where I create an algorithm to detect the face first, and then having a data set, pushing those data set to my machine, to my deep learning model to understand whether the face is having a mask or no mask. So this is one such implementation which was done. And also I could even show you another implementation of to detect facial emotions. So I could say that yes, emotion detection. So what if I can able to detect the emotion of human beings by seeing their face? Yes, that can also be a good application, right? So for example, this is me like neutral when I'm happy. This is happy when I'm angry. So it's like showing me sad because I'm not good that that good at expression. But yes, this can also be utilized in a lot of areas. Since the fact the lighting condition which I have is little less, which is actually like jeopardizing this particular input, particular output. But yes, we can easily classify a lot of stuff when I like move to a good lighting condition. Yes. So happy, sad, so whatever it can be, you can just like that you can showcase it out. So these are few of the applications which I can show. And I do have a lot of application to be showcased. But yes, it's very simple and very easy to achieve things. But the important factor is like how do you fine tune it. So that is where the beauty comes into play, because with a decent amount of time we could create good application. But yes, if it fails on certain situation, how do we mitigate that? On that time, hyperparameter tuning and mathematical computations comes into play. So try to understand the basics of the mathematics and how does a hyperparameter tuning works in a neural network, so that we could even fine tune our application to a real time node, so that we can able to deploy things in a real time market. So this is what a deep learning works, and this is how things and stuffs have been put it inside the components. So I believe that you got some a good insight about deep learning and the components inside it. But in the coming sessions, you will definitely will try to understand in detail about the implementation part, like some hands-on programs will definitely suffice the contents which I'm trying to say. So thanks for this wonderful opportunity. Since the time is of the essence, I want to run to another agenda. So I'm just finishing it real quick. So is there any questions I could answer right now? So this is a rhyme, so I can spend some 5 more minutes to answer down your questions if there are any. And yes, if there are no questions, I guess I could leave for the moment.
Good morning,
Hello.
sir.
Hello, sir.
I'm Peter Stanley. Peter Stanley, Dean Academics.
Hello, sir.
Very interesting. I was listening to your lecture right from the beginning. And during introduction, they told that you were involved in the rover also, the Mars mission.
Yes, sir.
Yeah. But I have few questions. Unfortunately, they are not able to test the rover there because of the unfortunate incident. But I just want to know what type of is it some kind of AI you have incorporated in the rover, or what? It's what type of software?
So like actually it's like a real-time implementation. It was for it happened on 2013, sir, in IIT Kharagpur, where
Yeah.
we done a project that satisfy a challenge actually. So the challenge is all about to like a situation in moon, where we try to push the rover to different situation and to drill some areas to get some samples. So the best one who's going to like do lot of drillings and taking the samples out of it will be given the best price. So during that, we designed a different ideology on like cost cutting technologies. Made a small robot that could able
Yes.
to, easily, mitigate those kind of problems. So that was
Okay.
the
Okay.
work which I've done, sir.
Okay.
But that was previously. Yes, sir.
Yeah,
Yes, sir.
since you were with the team, just I want to know, because this is something developed there in collaboration with the IITs. See, that satellite with the robot, when it reached near, it actually became fully autonomous.
Yeah.
Okay, fully autonomous. The thing is, why they didn't have a plan B? Because it actually tilted somehow some reasons, right? But why they were not able to do it here? Because that's a failure, no? Why
Yeah, I
there
mean,
was no plan B?
yeah, that is a good question. But actually, like
Uh,
the very mission was to, I mean, to test fire the rover autonomous functionality. But the main functionality is to put the satellite on the to
yeah,
the
yeah.
place where to understand the geographical locations. But yes, they were unfortunate to have some other plans which doesn't work out on that time. So,
Okay.
so
And I'm not taking your time. Huh? One
no
more
problem.
question about self-driving cars you were mentioning.
Yes, sir.
The thing is, because everybody is talking about self-driving cars, and it has come to practice also. And just I want to know whether they have some kind of deep learning model inside.
Yes, sir, definitely. Even my company in Michigan, they are they have implemented two cars, one in Audi and one in Lincoln, where they incorporate a lot of deep learning techniques to detect human beings and even to smartly pass down. Overtake cars in different lanes.
Oh, that
So they test fired it, and we have been using those. Incorporating this algorithm for the past couple of years, sir. So there are like
oh,
a lot of deep learning algorithms where have been utilized there.
because as you have mentioned, every day we are using AI software, machine learning, and so on. Because you were mentioning about the Google Lens and the Google Assistant, and even the Amazon Alexa, right? Natural language processing. Everyday, day-to-day life, without our knowledge, yeah, everybody is using the advantage of AI and machine learning. And the one question is maybe I think with your experience you'll be able to say that right now in Japan I recently read that they have come out with a robot. Even I tell the name Erika, right, to incorporate self-desire. In the near future, can a robot be conscious?
Yeah, that is a pretty typical debate, sir. Actually, I can say that it can become conscious, but with the technology which we have right now, I mean the advancement which we have right now, we are actually like focusing more on advancing our human capability. So that's where we are pointing towards. But yes, it is a sub product. I mean, like getting some conscious and stuffs. But with the current research, we are actually scratching the surface right now, sir. So we haven't reached to the actual core point of it.
That is true because whatever development that takes in AI and machine learning, we are trying to augment with a human being because we are going to live with them. Okay. So at one point we come, people are talking about the super intelligence and so on, where these things will overtake us and so on. Very interesting articles that are going on. But you, your presentation was very nice. I think you have taken so much time to actually give it very efficiently and very informative, and the slides are very good. Just I want to tell that also. Thank you,
Thank you, sir.
sir. Thank you
Thank you
very
so
much.
much, sir. Thanks for the opportunity, sir.
Thank
Deepan sir, thank you sir, very much for your wonderful session. Now it's break time. At 11:15, the next session will be started.
Okay. Thank you, ma'am. Thank you, everyone, for this wonderful opportunity.
Thank you so much, sir.
Bye bye.
Participant, I hope you had a nice refreshment. Next, we start a next session that will be handled by Anureka ma'am from IRTT. Mr. Srinivasan sir will introduce our resource person now.
Thank you, Nitya ma'am. I'm very happy to introduce the session to speaker, Dr. R. Anureka. Completed her BE in MGR Engineering College, Chennai. Did her ME in KSR CT, Erode. Completed her PhD in the year 2013. Her total experience is around 16 years. She has both in national and international journals. She is also a reviewer for 4 international journals. Currently, she is working as an assistant professor in IT department at Institute of Road and Transport Technology, Erode. We are very much happy to have her session today. I hand over the session to Dr. Anuradha ma'am. Thank you. Anureka ma'am, thank you.
Anureka ma'am? Ma'am?
Thank you for the introduction. I'm here. Yes, Nidya, I'm here.
Okay, ma'am. Okay, ma'am.
Good morning to one and all present here for the AICTE sponsored STTP on deep learning applications and challenges to big data analytics. Am I audible, please? Is my screen visible?
Yes, ma'am. Yes.
Okay, thank you. Before we begin, I'm Dr. R. Anureka, and I'm a professor, assistant professor in IT department of IRTT College, Erode. And I would like to thank all the management and staffs of Vellalar College of Engineering and Technology for giving me this opportunity to talk about introduction to big data and its challenges. Before we move into the topics, what do you mean by big data? Currently, the world population is more than 7.2 billion, and we have billions and billions of people who are connected to the internet, and these people are generating a tremendous amount of data through the use of electronic devices and applications, apps, what we call them. Apart from all these people or human people who are generating this information, we also have some automated devices like sensing devices, remotes, GPRS, and all those who are generating their own set of data. With the result that there is a tremendous volume of data which is generated every second of the day. These data are characterized by 3 aspects. One, the data is huge. No matter who is generating the data, what type of devices, whether it is automatically generated or whether it is human generated, the volume of data is enormous. And one of the major aspect of this device is it cannot be categorized and put into regular relational databases which are used in small scale application or even large scale application, because this volume of data is unstructured in its nature and too much work needs to be done in order to bring it to a format, store it, and then make use of that data. So such type of data is what we call as a big data. Another important aspect of big data is the data generation, capture, and processing. All of these 3 aspects have to be done very quickly. The data generated is very high in volume, but they need to be captured and stored. When I have too much incoming data, I need to have an application which is capable of handling that amount of data. As soon as it is generated, I need to capture the data which is generated, and then I need to process the data also in order to get an efficient information system or efficient knowledge from the system, which will be useful in its timeliness. What is the framework for any big data application? First, I need to know what is the problem. For what is the issue for which I am creating this application? What is the foundation or problem for which this issue is being handled? Next, I need to find out what is the type of data which has to be collected and how to handle the data, the cleaning, extraction, storing, structuring, all those type of what we call as data handling. The third step of that is the analysis and modeling, which has to be done on the data. And finally, once the analysis is done and the results are incoming, I need to interpret the result in order to convert it into knowledge. Before we go into all of this data collection, hope you're doing and everything, let's see some of the characteristics of big data. First is volume. The quantity of generated and stored data is what we call as volume. The size of the data determines the value, what is the insight which can be given, and whether we can consider it as a big data or not. Here, the potential problem here is, given the data, will it be useful or relevant to the current problem which I'm trying to solve? That is what we are going by volume, the quantity of the generated and stored data, and whether it has any value or whether this data is useful or relevant to the current issue for which I'm generating the application. Second is the variety of the data. What is the type of data and what is the nature of data? Here, type of data means when we are talking about type of data, whether it is structured data, unstructured data, semi-structured data, whether it is raw data, and whether it randomly changes or whether it is in a linear scale, what is the proportion of data, whether the information is coming from a single source, whether it is coming from multiple sources. That is what we mean by variety of data. Structured, unstructured, semi-structured type of data, and whether we have existing tools and technologies which are capable of handling the data, the capturing, storing, and processing, of the data. Third one is the velocity, the speed at which the data is generated and the speed at which it can be processed in order to meet the challenges that lie in the path of that application. Say, for example, I have data. Let's take the three characteristics itself: volume, variety, and velocity of data. Now, assume that I have, let's take Google Apps application. Okay, I have multiple persons who are journeying through a particular destination, or assume that your mobile devices has location sensing enabled. The location is enabled, GPRS is enabled, which implies you're constantly sending some information about where you are. And if you're in a vehicle and moving from one place to another using Google Maps, then it also indicates the time taken from source to destination. If you've just enabled the location sharing, but you're not moving or anything, you're not using the Google map or anything, but still that information is enabled or sufficient in order for them to generate or give you information about what should be the traffic pattern to expect today. Okay, if you're a regular user of Google Maps and you're regularly going from one location to another, it may be from your, assume you're going from your home to your college, it is a regular thing, your location is enabled, so every day they know that at 8:30 you're leaving your home and you're reaching a particular destination by 9 o'clock. So this is a pattern which has been inferred from your moving history or from your location history, and based on this, if I know the current status of traffic between the point A and B, between your home and your college, I can predict the time which will take for you to reach from your home to college, and this information can be conveyed to the user. But this information generation, okay, at 8 o'clock, what should be the information? At 8:05, what is the status of the traffic? At 8:10, what might be the status of the traffic? How to predict that information? The timeliness of this is going to be a huge factor. If I'm going to analyze the data and then say at 9:10 that it will take you half an hour to reach from your home to this, in a normal circumstances, today you have huge volume of traffic. It might take you 45 minutes to journey from this, and I'm giving you this information at 8:30. It is not going to be useful because I have to reach the college by 8 o'clock, by 9 o'clock. So the timeliness, which implies what we mean by velocity. That is a huge volume of data which is generated from Google Maps or from other traffic sensing information that they have received. It has to be processed and delivered to the user in a timely manner for that information to be useful. Beyond that time, that information is useless. So when I say velocity, it depends on two things. What is the volume of traffic which is generated? Where I'm getting this volume of traffic from? It may be from devices, it may be from how I'm sensing this information. From a variety of sources, I've gathered this information and I have a huge volume of data. All this information has to be processed at a huge speed for that information to be useful in a timely manner. That is what we mean by velocity of the data, which is being continuously generated and processed. Next is veracity. Veracity basically means what is the quality of data and what is the data value. The quality of data will quickly or it will impact the accuracy of the analysis. This is a very important factor where we are generating or where we are gathering that information and how true that particular information is going to be. Like I said, value refers to the utility of the data and the processing which has been done on the data. And variability refers to other influencing factors when I'm generating the data or processing the data. What is the relationship in the context by which the volume of information is generated and processed? That is what we mean by variability. Other important characteristics of which influence big data are exhaustiveness. Whether I have captured all the related data. Say, for example, let's take the traffic example itself. Okay, under normal circumstances, I have a 30 minutes journey from point A to point B. Suppose I say that I have a weather prediction which says that it might rain between 8 and 9 o'clock. Then I need to that information should be included when I'm deciding the traffic pattern, because whether if it is raining, it will increase your journey time. So we have to consider whether all the relevant data has been added when I'm performing an analysis. Exhaustive, whether I've captured and recorded all aspect and other influencing data for that particular application. Next is fine-grained and uniquely lexical. What is the proportion of data which is included? Whether every element has been considered, what are the characteristics of the included information, whether they have been ordered, indexed, and properly analyzed before the information is being added to the analysis. Next is relational data. Like I said, traffic patterns and weather patterns are two totally unrelated fields where each one are generating their own set of information. But I have an influence or relation between the two data. Those relational aspects needs to be considered when an application is being generated. What are the common fields? Whether I can to relate from a different data sets also, and whether I can perform analysis or meta-analysis of other data sets also. Next is extensional. Sorry. Hello.
Yes, please, ma'am. We can hear you.
Yes, thank you. I have other characteristics. The screen share is okay. Are you able to see the screen share, please?
Yes, ma'am.
Okay. Sorry for the break. Other characteristics of big data includes exhaustiveness, whether the entire system has been captured and all the relevant data has been added, whether it is fine-grained and uniquely lexical, what is the proportion of the data which is collected, whether all the elements related to that has been captured, whether they are indexed and structured. Next is the relation, whether common fields have been considered, and metadatas and all that has been ignored. Next is extensional. Like I said, consider you have a person or patient data which is being captured. Initially assume that he has only diabetics. His name, age, his history of medical related to diabetics will be available. Assume at some point of time he is also having a secondary problem which may be related to his heart or kidney or something like that. I need to be able to extend his data set in order to add in the new data and how it is going to affect his previous data also. Extensional of existing data in order to include more fields, and the size of the data will also be increased with respect to scalability. These are some of the major characteristics of big data: volume, variety, velocity of data generation, veracity, the velocity, value, and variability, apart from these other characteristics. Let's see who are the major contributors for all this data generating or for the data which is being generated. Surprisingly, it was the government which was responsible for the major volume of data which is being generated. We may think it is the entertainment industry, it may be the media, it may be social, it may be Facebook, Twitters and all that. But actually, the government is the major contributor with regards to data generators. Now consider the CRBS, which is the Civil Generation and Vital Statistics. This is a database which is almost every country will generate this. Okay, this includes registration about a person's birth, death, his marriage certificates, his property informations, all the, when I say properties, what is the history of the property, who held what and all that, divorce certificates, marriage certificates about an individual. This, assume in India alone we have 1 billion people, so every people will have his birth certificate if they are already died and who is currently living and all those details, who married whom, what is the divorce statistics, what are the details about the properties which is generated in India for 1 billion people. You can imagine the whole volume of data which is generated for just CRBS alone. Now consider you have your other for in India. Okay, in situations or advanced countries like America, this data is going to be even more huge, where you have your social security number, which has your history and geography of everything about a person. Okay, here, suppose we are considering Aadhaar. Okay, there are 3 types of information which we record in the Aadhaar. First is your identity information. What is your name? What is your address? What is your date of birth? What is your phone numbers which is generated? And those type of information, your parent information, spouse information, those type of information. Then you have your famous biometric information, the photos in the Aadhaar, your fingerprints, which is your 10 fingerprints. Apart from this, you also have your iris scan. For 1 billion people, I'm having 10 fingerprints, iris scans for left side and right side, and biometric information. What is the volume of generation data for just only the biometric information? So now add in that, we have also linked our PAN cards, LPG information, banking information, or passport information. All of this again are linked to your Aadhaar, which implies that the total volume of information about a single person is huge. When it including the entire nation, the volume of data is going to be simply enormous. Similarly, police records, banking records, and all those informations again are another major generator or contributor towards your data generation. Other areas or other fields which are generating huge volume of data includes, next to that, your healthcare institute. Healthcare, person information, his what is the medical condition, medical history, what were the tests which were taken, what were the reports which were generated, what was the prescriptions which was given for each time, how many times he visited his doctor, the entire medical history plus the person's personal informations. All of these will contribute to a huge volume of data. This type of data, what is the use of Dina? We also have research and analysis. These type of informations are a huge contributor towards research also. Other important areas includes education, science and technology, which includes, consider your internet. How many websites are available? How many web pages are available? How much information is available on the internet? How much you access those information? What is your search history? What is your preference? So much data is available with respect to education and information. Then you have your media and entertainment industry. The volume of data available in these 2 sections, media, entertainment, and social media, is too much. For Facebook and Twitters and everything, the volume of data generated per second runs in zettabytes, which is millions of terabytes. No. Another major contributor is sports. Say, for example, how does sports contribute towards data? They are another huge factor in data generation. For example, assume sensors and sports. They can be used to improve the training. What is the breath rate of a person? What is the heart rate? What is the impact of falling down? What is the impact which happens? What is the force with which a ball moves? And all those type of informations can be used in order to predict or analyze how to handle certain situations. Now, another famous industry with respect to sports is Formula One racing. You know, that is most costliest one and the most competitive, or it is the pinnacle of racing achievement. You have a Formula One race cars. We have hundreds of sensors within a single car. Apart from this, you also have sensors in the driver's suits, visions, Googles, and everything, which collect per second. It collects huge volume of data with respect to what is the car pressure, what is the impact, what is the speed, what is the oil pressure, what every information is collected, tire pressures and everything, every second, and the data is sent to a collection unit from which they perform the analysis in order to make some adjustments. These analysis is used in order to improve the existing thing. Every second the information is being collected. The application of big data is huge in these type of areas. Other important contributors include finance, banking, insurance, stock exchange. The New York Stock Exchange is responsible for generating almost 1 terabyte of data per second. I'm talking about per second of data. Then you have your hospitality industries, hotel management, tourism, transport industry, productions, retail. Say for example, retail, let's talk about, say, Walmart. They handle almost 1 million transactions every year. And this transaction, if I'm translating into data, is more than 2.5 petabytes, which is 165 times the volume of the total data available in a library, US library, Congress library. It is very huge volume of data which is generated by each industry. Amazon handles almost 1 million hits every second. Can you imagine the volume of data which is being generated by Amazon? What is the user? What is the preference? What is the age group? What they are searching? I need to analyze this information and also give certain suggestions also. If I touch one application, or item, if I'm touching, automatically at the bottom, I'll get people who browse through this also bought these type of tools or other items. Those types of suggestions have to happen for almost, like I said, 1 million users at a second. It means 1 million users, I should be able to be capable of generating or processing that information and generating the response for that particular person. This is a huge application of big data. Now, before we go into applications, how we are doing this, what is the analysis steps and everything, there are 5 major steps in how the data is handled with respect to big data. First one, like I said, I need to know what I'm going to do. What is the issue that I'm going to solve? If I'm going for traffic pattern analysis, I need to calculate the traffic data. If it is about advertisements, who I should advertise with, those type of, what is the problem formulation, and then what is the raw data to be acquired for that related to that particular problem. These informations can be generated by various sources, and there is no predefined standard for generation or storing of this raw data. Second step is filtering, cleaning, and extraction. Whenever we need to make some decisions, the volume of data which I am generated and received is generally in an ad hoc manner. As soon as it is generated, it is received. There is no structure in that data. There is no reasoning or nothing. I'm just getting raw data. Next, I need to decide on the filtering process, what to keep, what is relevant to my application or the current issue that I'm trying to solve, and what should be discarded, what should be cleaned and stored, and how to keep that information reliably, how to label the data, and once the data is obtained, how to extract some useful information from that. Say, for example, I'm trying to get the MRI scans of patients. I will have a huge set of videos for that MRI scan. Now, the videos are not going to be giving me any useful information. I need to know how to extract data from that MRI video. Say, for example, I have geographic security footage or secure surveillance videos. The surveillance video is the data, but the data has to be converted into some useful knowledge. How to extract data from an image or a video or a text. That is another major factor for big data analysis. Once the data has been extracted, I need to perform the data integration. Like I said, information need not necessarily be from one source. It can be from multiple sources from totally different fields, all of which may be required in order to make the analysis or prediction. So what is the data aggregation, integration, and how the data should be represented? This is another major aspect of this, which is required for manipulation of the data and to perform some error-free results. The fourth step is the analysis and modeling. This is the area where we are using various technologies which are available for analysis, mining, whatever tools we have and all that, how to visualize and represent the data which has been resulting from that data. What is the hidden pattern? What is the relationship between the data which has been given? Whether we can identify some clusters or data models, predictions, all of these falls within the fourth step, the data analysis and modeling. Once the analysis has been done and the results are generated, I have two possibilities here. One is automated inference. Say, for example, that Google map. Okay, I have a huge volume of data. I need to predict whether there will be any traffic, whether there will be any traffic congestion. What is the time which is going to take a person to reach from person A to person B? Given all that information, it is possible to predict what will be the traveling time for a particular person. So this can be done. Automated result analysis can be done. So this is one type of decision making, automated decision making or interpretation from the result. This can be done using algorithms or artificial intelligence to support the decision making, and the system can also be self-learning. Say, for example, weather reports. If I have these or the pre-existing condition, there is a possibility of rain, there is a possibility of snowfall. These can be done. Automated result or decision making can be done. There is a second possibility in interpretation where when I'm making the initial decision on what is the data to be taken, I'm making certain set of assumptions before I decide on what data I'm using, what is the processing to be done. Okay, there are some crucial assumptions which are made. These assumptions play a major factor in the result and interpretation. Say, for example, same Google Map explanation. I'm assuming only the Google Maps and I'm not considering the weather pattern at all. The result may be wrong if I'm going to have a rainfall or snowfall that day. Okay, if it is a rainfall, it may be slower. If it is a snowfall, it is going to be very, very late. Okay, so the interpretation is based on the assumption. Assumption plays a crucial factor in the final analysis. This explainability and interpretability is done, or it may require human intervention when such assumptions are being made. Once the knowledge has been retrieved from all of these 5 steps, the result will also act as a feedback in order to fine-tune the next analysis which is being done. What is the ambiguity or can be also removed, errors can be corrected, and a better analysis can be done in the next step. The feedback-based analysis has to be done. So once we have seen all of this, let us find out what are the actual challenges in big data. I have, like I said, we have a huge volume of data, it needs to be done on time and all that. Let's break it down into a fewer challenges. First one, the major challenge in big data is the big data paradigm itself. The basic concept itself is a challenge. Say, for example, I have a huge volume of data and there is a difference between performing a macro level analysis and a micro level analysis. Say, for example, you have your class result. Okay, a macro level analysis is how many students have failed in a particular examination. A micro level analysis may be how many students have failed, what are their information, what is their medium of instruction, what is their previous history of examinations, what was the result which was obtained from them, what was his attendance levels, what was his test history, internal test marks, what is his rest. These are micro level analysis. A macro level analysis stops only at the percentage of result. So the big data paradigm is saying this, that a shallow analysis can be done when I'm going for big data analysis, because it is only performing the analysis at the macro level. The result is a shallow analysis and the accuracy may be lost due to the sheer volume of data which is being generated. Second, there is another problem with this. Okay, I have millions of data. Am I going to take a sample of the data, or I'm going to use the entire data in order to perform the analysis? What is a sampling data? So major on the all the tools and techniques and data mining other technologies which we are using depend on sampling technology. So if the samples are not correct or it is not taken properly, the result is going to be wrong only. Okay, so in the basic concept here, the huge volume of data, how I'm going to handle the data? Take everything or a sample. If I'm taking a sample for that huge volume of data, was the sample fundamentally correct? Second, how the prediction, there's another important aspect of big data. Whenever we make a prediction, we make the prediction based on previous history only. Say, for example, September is supposed to be a month with heavy showers. October, November, we don't have any showers at all. April, we don't have any rains. It's going to be very hot. Now, what happens if I have a low pressure forming in this? Okay, so initially the prediction was April was going to be very hot with no showers, no rainfall or anything. Suppose suddenly there is a low pressure which is formed in the Bay of Bengal or somewhere else like that. Okay, we can definitely know that we are going to have some risk. The prediction is based on history. It has to take existing conditions into account also. If not, I can't always say the future is going to be similar to the past. That type of predictions will result in wrong analysis and results. The next major challenge in big data is how to extract information. This is the process of converting the data into valuable information. The first, excuse me, any problem? Excuse me. Hello. Hello. Any problem? Hello. The next step is extracting information, which is the tricky process of converting the big data into valuable information. First to be considered is the data itself. The result of analysis is only going to be as good as the original data from which the information is taken. Now, the problems associated with data is, what is the number of data? Hello?
Participants kindly unmute. Ma'am, Anureka ma'am.
நான் mute பண்ணிட்டேன் அந்த user. Can you see the screen? Any problems? Can I continue?
Anureka ma'am.
Yes. Yes, Nitya.
Ma'am, you can have an option of unmute participants.
Okay, okay. Extracting information from data. What is the number of data sources? How heterogeneous? What is the scale? What is the timeliness in which the data is captured? What is the complexity of the data? And what are the security issues related to the data? Once the data has been acquired from multiple sources, I need to synchronize the data across the data sources and get the information into some form of structured format which can be used for analysis. Second, next problem with related to data is what is the reliability of the data and what is the quality of the data, whether it is being completely acquired, whether it is partial, whether all the data is available, what is the sample which is taken for analysis or all data is taken for analysis, the completeness or quality of the data, what is the reliability of the data. Another major aspect with respect to data or challenges in data is, has the data been compromised? I'm working on the data on the assumption that nobody has manipulated that particular data. Suppose the data has been manipulated or modified in some form, then the result is going to be compromised. Another major challenge with respect to data is the data quality. Say, for example, I'm performing a election evaluation. Okay, I'm going to predict the result of a particular election. It may be the presidential election or the state elections or national election. I'm going to predict the result of the election using Twitter data or Facebook data based on the user opinion on who is going to win the election. This data is never going to be correct. I may acquire a sample and perform this, or I can use the entire data set. The problem is that everyone involved in the elections are not going to post their opinion about that on the Facebook or Twitter. So the data quality is skewed because it does not represent everyone who's going to be involved in that particular election process. Results drawn from such sources will lead to wrong conclusions only. That is why information taken from Facebook or Twitter are never correct with respect to elections or awards. Another respect to this is unreliability of the data. Say, for example, I have a patient with, say, COVID-19 situation. Okay, I take in the consideration what is his age, what is his gender and all those information, and I predict that if the person is between 20 and 30, he's definitely not going to, nothing is going to be affecting for him. Now, suppose the same person in the medical history, don't have the information that he is an asthmatic patient with severe lung problems or breathing problems, then my result is going to be wrong. It is going to be critically dangerous for that person to survive the COVID-19 situation. So this is what we mean by incompleteness of the data or information, lacking information. The completeness of the data is lost here. Next is, once the data, all these challenges, then you have the technologies which are available in order to handle the data. There is a huge variety of technologies which are available, and I lack or may not lack the skill set. What is the talent required in order to execute them? What is the availability of the skilled personnel in order to manipulate the data, interpret the result and everything. Another major challenge in big data is understanding and acceptance of big data. This includes, generally big data, they focus only on the computation. I have a huge volume of data. I need to perform the computation very quickly. I need to store this information. I need to extract that information. I need to perform a sample and all that. I'm focusing on the computation and volume of the data. But what about the perceptiveness of the result? How to understand that information from that data or from that result? That is another major challenge which has to be considered with or in addition to all the data that we are worried about. The interpretation and results should also play a major factor, which is one of the biggest challenges because nobody is very worried about that. They say that if the tools are available, if the mining is done, if all the technologies are used, I'm going to generate the result. Now I need some personnel here in order to interpret the result and tell me what is going to happen based on that result. Another important challenge in big data is cost. how to gather the data, what are the devices which are going to be required in order to gather the data, how to store that volume of information, what is the computational power which is going to be required in order to calculate the result, and what is the time factor which will influence this such that the information generated will be useful. Like I said, I'm going for traffic analysis. It's going to be useless if I reach the college and then I get the traffic analysis. The timeliness of this, that depends on the computational power and everything. So the cost involved in big data is going to be very huge. Another major aspect or challenge in big data is the scaling and updating. Whether I can add more fields to that, whether I'm going to add more contributors to that, who's generating the data, how to update the existing information, how much information should I take when I'm predicting certain aspects, say whether I have to take for 1 day, 1 year, 1 month, or last 10 years data, how to update that information, how much longer that information should be stored. So if I'm having new information which is generated every day, I need to know what to do about the data. Say, for example, if I have weather reports, do I need the weather report today, tomorrow, day after tomorrow, after 1 year? Maybe yes, because I need to establish a pattern and study and research the pattern from what is the pattern for the last 10 years, how it has deviated. So these type of information should be kept for longer periods of time in order to generate a pattern and then use that pattern for prediction of futures. Same way, scaling of information, how to store the volume of data which is generated every second. In past, the weather report may be from 10 sources. Today, it's going to be millions of sources. So how to scale the storage, how to scale the processing capability, how to keep the updated information with respect to data, technologies, and other aspects of this. These are some of the huge challenges which we face in big data analysis. Let's see some examples of what are the challenges in big data and how they are applied in real-time situations. Say, for example, the most famous, these are some of the benefits of big data: scalability, access to more information, integration from different data sets, like I said, traffic and weather patterns, medical history and locations, geographic informations, patterns, all those can be available with big data. Let's see some applications of big data and challenges which are faced in every aspect. The most famous application is Orion, on-road integration, optimization, and navigation system. This is an example for the parcel delivery services or premier courier service agency. So for example, I have Amazon shopping and I have AICTE. Okay, AICTE is responsible for delivery of my products. Now the delivery at E-Road, say for example, one particular location I'm considering, I need to perform what are the items which are available, which are the areas in which they have to be distributed, and I have to perform a delivery path from source to destination, or such a your traveling salesman problem. Basically cover all the areas at least once or only once, and then make sure all the items are distributed correctly within the time system. Now I have some influencing factor which says that one person along the route may say, I will not be available up to this time. I may need to, you need to deliver it at this time only. If I have a working place, it is working only from Monday to Friday. Saturday, Sunday, the delivery is not possible. It has to be postponed to Monday only. So I have certain assumptions, some critical factors which have to be considered when I am drawing the algorithm for the delivery system and how to perform this. I have to perform a route optimization technique such that every element or every stop on the grid is analyzed, and I have to make sure that the delivery person can save or effectively deliver the information or products at the route, and this will result in huge savings with respect to time, money, and efficiency also. for example, the education system. Assume I have a student's academic performance, and based on the academic performance, I can make some suggestions saying that he is very strong in English. He doesn't need much time for English. He is very weak with maths. He needs more coaching with maths. He needs more specialized training for maths. See, he may be very strong in science and analysis. He may be weak in some other subject. He has a strong tendency or aptitude towards extracurricular activities. All those types of information about a particular student is available, based on which I can perform a personalized timetable for that student, which includes the number of hours which he may need to perform for each subject and how the information should be distributed so that he can perform, or what are the additional courses which may be specified or designed for that person, extra coaching for maths, or special attention to his extracurricular activities, special attention towards his sports activities. Those type of educational timeline can be given for a student. If he is a very advanced learner, what are the additional subjects which may be prescribed for him, whether he can go for some additional activities for that person, so advanced coaching for the person, whether he is a slow learner, he may need more time for that particular person, how to group students according to that, how to generate a timeline and a timetable for each student. Those type of analysis can be done here. Okay, this is in the future. Like we said, what is the application of this? We need huge volume of data in order to make this prediction at all. It is not just for one student, but a bunch of students for one particular school, which may be applicable to the entire nation, how to use that particular information. Other famous examples, or like I said, I've been using the Google Maps, traffic signals and all that. In Google Maps, say for example, I have 20 or 30 vehicles which are using the Google Map to go from a particular location. Say for our example, from Bangalore to Hyderabad, they are moving. Okay, all of them have enabled the navigation system based on the number of vehicles. What is the time taken to cross from one particular location to another particular location? Say for example, between Hyderabad to Bangalore, I have 4 stops or 4 points, I can say A, B, C, D, 4 points. What is the time taken for all the 20 vehicles to cross from point A to B? What is the time taken from B to C? If the time number of vehicles are slowing down, what are the influencing factors? Whether it was daytime, whether it was night driving, because people tend to go slower during nighttime than during daytime. Whether there is a weather pattern which is affecting it. What is the speed at which the vehicles are moving? What is the time taken from crossing point A to B? All of these can be used in order to determine whether there is a traffic congestion in a particular route. If at all there is a traffic congestion, suggest some alternate routes. What is the time taken if I'm going to take an alternate route from point A to C without going through point B, because there is a traffic congestion there. So these types of suggestions and applications, they have to be done very quickly. And this is real-time data, which is required within a particular time duration, and what can be done with that data. Say for example, like I said, Amazon shopping. I have millions of data users who are using shopping daily. Now consider a situation, I'm clicking one particular data or an item. Okay, it may be anything, say a wristwatch, or it can be a footwear or anything. I've clicked one particular item and I'm browsing the specification. Automatically at the bottom, I will have certain suggestions saying that if you like this, there are other similar products to this. You may also consider this. People who bought this also bought these items also. Okay, there is a correlation between what we are buying. Say for example, a person who buys milk will definitely buy bread. Okay, so what are the types of bread which is available in your pantry? What are the types of jams which may be available in your stock? Those type of informations can be given. So shopping, that suggestion has to be generated, and association between or relationship between the products has to be established beforehand. And I also need to know my history, whether I'm browsing certain information or I'm just going to buy that. And a history of shopping will also be useful in order to make a decision on what to offer, what are the items which I may be interested in, and what are the suggestions to make for a particular person. So These are some of the applications, or it shows you how much data is going to be generated, how quickly the information has to be processed, and how quickly everything has to be done in order to make it useful for the user. I'm not just generating the data. I have big data. I have a huge volume of data. It needs to be processed. I need to perform some inference based on this. Another crucial factor of big data is the timeliness. The data should be complete. The analysis should be perfect. The sampling should be done correctly. The predictions or results should be done, or it should be reliable. And based on the result, I have to perform some inference. All of this have a time limit before which the whole information is going to become useless. So all of these combined together form the major challenges for big data and big data analysis. In conclusion, I can say that I have a large volume of data which has to be transformed into knowledge. And in order to do this, I have a high performance, large scale data processing has to be done. This includes all the technologies, all the hardware which is required for storage, what are the technologies for performing the analysis, and the human interpretation of those results are also going to be involved. Even then, the result will have a large volume of uncertainty in different forms. The success and profitability of the information depends on the accuracy of the data and these predictions. There are many challenges which needs to be addressed before the success or profitability of the data can be achieved for 100%. Because apart from scale, the heterogeneous nature of the data, there is no structured data which is available. There is no privacy on the data. What are the security issues with the data? How to visualize the information, how to store that information. All of these play a crucial factor in deciding the big data challenges. All these challenges must be achieved in order to achieve the perfect result for big data. I'll conclude with that. Thank you for your patient listening. Anything that you want to discuss with me? Hope the session was useful. Hello. Any doubts, queries that you want to ask me?
Okay, there is no questions from your participants, so I think we all understand the topic. So now we can wind up the session. The next session will be at sharply at 1:30. You can join at the time. Thank you, ma'am.
Thank you, Nitya. Thank you for the opportunity.
Thank you very much, ma'am.